Hi student friends, I am presenting my next video on the topic Laplace Transform theorem multiplication by t raised to n. First of all, we try to see the statement of that theorem. If Laplace of f of t is equals to f bar of s, given or we can obtain it as f bar of s, then Laplace transform of f of t into t raised to n, that given function f of t multiplied by some t raised to n, it is given by the result on the right hand side is minus 1 raised to n nth derivative of f bar of s with respect to s. This is the statement of that theorem. We try to solve some example based on this theorem, or where we have to use this theorem. I am starting with a very simple example. Find Laplace transform of e raised to 2t into t. Here we consider that function f of t as e raised to 2t, and then it is multiplied by a term in the form of t raised to n. Here the power n is here 1. This same problem we can solve by first shifting theorem, which I have discussed in earlier video. Here I am not using that technique. I am using this theorem, multiplication by t raised to n. Therefore, we know that Laplace transform of e raised to 2t by using this standard result. Laplace of e raised to 8 is 1 upon s minus a. Here it is 1 upon s minus a is here 2. Therefore, s minus 2, s greater than 2. And we call this as f bar of s same. Okay, and therefore, Laplace transform of this e raised to 2t multiplied by t, where power for t is 1, therefore minus 1 raised to n is here 1, and nth derivative, here it is first derivative d by ds, because n is 1, therefore it becomes first order derivative d by ds of f bar of s, and it is equals to minus 1 raised to anything is minus sign d by ds of f bar of s. The value of f bar of s is 1 upon s minus 2, and it is equals to minus, it is in the form of 1 by x. The derivative of 1 by x with respect to x is minus 1 by x square, and as per that, its derivative with respect to s is minus 1 upon s minus 2 bracket square. Into chain rule, derivative of s with respect to s is 1, and therefore if you simplify it, we get minus minus plus 1 upon s minus 2 bracket square, a required answer. Okay, very simple. Okay, therefore once again I will repeat the steps. The first step, try to get the Laplace of that function f of t, call it as f bar of s by using standard results. Then use this theorem to find the Laplace of this e raised to 2t into that t as minus 1 raised to n is here 1, d by ds of f bar of s. Here put the value of f bar of s and then differentiate it with respect to s to get the result. 2 steps only. Next example, find Laplace transform of t into sine of at. Again, we consider f of t as sin a t, which is multiplied by t, means it is a problem for this theorem, multiplication by t raised to n. Therefore, performing the steps, we have Laplace transform of sin of at. Standard result, it is a upon a square plus a square. We call it as f bar of s, say, and therefore Laplace transform of sin at multiplied by that t, applying the theorem, it is minus 1 raised to n is here 1, and the same order derivative, here it is first order derivative as n is 1, d by ds of f bar of s, and therefore it is minus 1 raised to 1 is minus 1, d by ds of f bar of s, and that f bar of s is a upon a square plus a square. Okay, and that is equals to, here that a is constant, I can take it outside. 1 by x, the derivative of 1 by x is once again minus 1 by x square, therefore it is minus 1 upon x square, means here it is s square plus a square bracket square. As it is function of function, applying chain rule, the differentiation of s square with respect to s is 2s, and therefore if you simplify it, this minus minus become plus 2s divided by a square plus a square whole square. Final answer, or the Laplace of that term. Laplace of t sin at, I have not written this a, therefore the final answer is 2as divided by s square plus a square bracket square as a final answer. Next example, third example, find Laplace transform of t square into e raised to minus 3t. Okay, therefore here it is f of t is e raised to minus 3t, we have to consider, multiplied by some t raised to n type of term, here it is t square. Therefore, performing the steps, we have Laplace transform of that e raised to minus 3t as 1 upon standard result s plus a is here 3, a is here 3, and we call this as f bar of s, say. Okay, and therefore Laplace transform of this e raised to minus 3t multiplied by t square, using this result theorem, it is minus 1 raised to n is here 2, and same order derivative means d2 by ds square, second order derivative of f bar of s, and therefore it is equals to minus 1 raised to 2, sign is positive, d2 by ds square of f bar of s, and f bar of s is 1 upon s plus 3. This term we have to differentiate twice with respect to s, therefore I will split it, it is d by ds of d by ds means d2 by ds square of 1 upon s plus 3, and therefore outer d by ds I am keeping as it is. Differentiating this with respect to s, derivative of 1 by x is minus 1 by x square. By using that standard result, it is minus 1 upon s plus 3 whole square, and therefore it is equals to d by ds of, transferring this term to, therefore minus 1 upon, I am transferring this to numerator, it becomes s plus 3 raised to minus 2. Okay, and then using the standard result of derivative, it is minus n outside, x s to n, its derivative is n x s to n minus 1. By that standard result, it is minus 2 minus 2 minus 1, we get minus 3, and therefore if we simplify it, this minus minus it becomes plus 2 upon, transferring this in denominator, we get s plus 3 whole square. Answer of the required Laplace transform. Then next example, example number 4, find Laplace transform of t cos at, cos of at. Okay. Here we consider f of t as cos at multiplied by t, means the problem for this theorem. Again applying the steps. First step, find the Laplace of cos of at. By standard result, it is s upon s square plus a square. We call it as f bar of s, say, and therefore Laplace transform of cos at multiplied by this t, and applying this result on right hand side, it is minus 1 raised to n, n is 1, and first order derivative d by ds of f bar of s, and therefore it is minus d by ds of f bar of s. What is f bar of s? It is s upon s square plus a square. Therefore it is equals to it is in the form of quotient u by v. Therefore applying the result of derivative for u by v, or applying u by v rule or quotient rule, and therefore here it is denominator term s square plus a square. Derivative of s with respect to s is 1 minus s, derivative of this with respect to s is 2s, and divided by v square, means here it is s square plus a square bracket square, and simplifying it, it is minus s square minus 2s square, we get minus s square, and this one is a square. Therefore it is a square minus s square upon s square plus a square whole square. Multiplying by minus sign inside the bracket, we get the term as s square minus a square divided by s square plus a square and bracket square as the required Laplace of this term, or that is the required answer. One more example, find Laplace of finding Laplace of t square multiplied by cos h 3t, or consider here it is 2t. Okay. Therefore, we consider f of t as cos h 2t, which is multiplied by t square. Therefore, problem for this theorem, performing the steps. First step, write down the Laplace of cos h 2t. By the standard result, it is s upon s square minus a square, a 0 2 2 square 4, and we call this as f bar of s c. First step. Then Laplace transform of cos h 2t multiplied by t square. Applying this theorem, it is minus 1 raised to n, power n is here 2, same order derivative with respect to s of f bar of s, and therefore it is minus 1 raised to 2 is sign is plus sign, positive value, and d2 by ds square of f bar of s, substitute the value of f bar of s as s upon s square minus 4, and again it is second order derivative, split it as it is d by ds of d by ds of s square minus 4. Twice we have to differentiate with respect to s, and therefore it is equals to outer d by ds I am keeping as it is. Finding the value by applying quotient rule, and therefore applying that quotient rule, s square minus 4, derivative of s is 1, s, derivative of s square with respect to s is 2s, divided by s square minus 4 bracket square. It is d by ds of, simplified, it is s square minus 2s square, we get minus s square minus 4 divided by s square minus 4 bracket square. I can take minus sign outside, therefore it is minus d by ds of s square plus 4 divided by s square minus 4 bracket square. Again in the form of quotient, in the form of u by v, therefore applying the quotient rule to find the derivative, it is in the form of quotient u by v, applying quotient rule, and therefore it is equals to minus sign, outer sign as it is, this term v, s square minus 4 bracket square, derivative of this numerator term with respect to s, 2s, minus this one, s square plus 4, into differentiation of this with respect to s, its derivative is 2 times s square minus 4, chain rule, derivative of s square is 2s, and whole divided by square of this, and therefore square of that term is s square minus 4, square of square, it is 4, and therefore it is equals to, from this I can take s square minus 4 as common and 2s also common, therefore minus 2s a square minus 4 common. When we take this one as a common, here it remains a square minus 4 remains, and minus this is taken common, this also I have taken common, therefore what is the remaining? 2 times a square plus 4 divided by a square minus 4 raised to 4. And if you simplify it, minus 1 get cancelled, therefore 2s divided by a square minus 4 raised to 3 multiplied by. Therefore, simplify this term from the numerator. S square minus 2s square, we get minus s square. Minus 4 minus 8, minus 4 minus 8, minus 4 minus 8, we get minus 12. Minus 4 to the 8, and divided by a square. Okay, I have written. Okay, and therefore final answer, multiplying by a minus inside, we get, it is 2s multiplied by s square plus 12 divided by s square minus 4 bracket raised to 3 as the final answer of the required Laplace transform. Therefore, with the help of all this example, I have explained how we can use this theorem, that is multiplication by t raised to n to f of t, and how we can find the Laplace of that function. In next video, I will explain the next theorem, that is how we can find the Laplace of f of t by t, means division by t. Theorem for division by t. If you are watching my videos, like, share it, as well as subscribe my channel for new updates.